I'm teaching a discrete math class right now, and my students are learning how to write proofs. And I have the same theorem written in 4 different ways. This is a simple theorem. If you have an odd integer and you square it, it remains odd. And I think a lot of people would say, oh, a student does or doesn't know how to prove this theorem, but I think it's more complicated than that. I think there are a lot of students who would be able to prove this if you stated it in some of these ways and would not be able to if you stated it in the other way. And I don't think this is because they don't understand how to prove the theorem that the square of an odd integer is odd, but it shows that these little quantifiers and the different ways we use language are some of the more important things for students to try and grasp. Right, this top one, I very helpfully put the if-then statement in its own line. I think students would be able to see that this is the hypothesis and this is the conclusion. And this is still the same if-then statement, but I put the if clause at the end, which we sometimes do. Here, I've got this correct quantifier for all integers x. If that integer is odd, then the square is going to be odd. I think a good teacher would know how this is going to confuse students, what they might write, and what to kind of expect and talk about and give them practice with when dealing with these quantifiers. And then finally, maybe this is the easiest version where we actually write the word assume, which is maybe what we want the students to write in their proof. This is really helping them out. Notice I didn't even use the word integer in the statement, but I just kind of have this global domain of integers so that maybe the students don't have the potential to write something like for all integers x. Right? So if I say for all integers x, if x is odd, then x squared is odd, a very common mistake that a student might reasonably write is they might suppose for all integers x, x is odd. After all, that's like the first part of the statement, isn't it? But if you phrased it this way, I don't think the students would write that because there isn't the for all in the statement. I think even if they didn't understand that for all turns into a let or some other English word, you might get a correct answer down here. So 2 different professors could give the same question basically, but phrase it just slightly differently. One might conclude that their students do know how to write the proof. The other might conclude that the students don't know. Now, I'm not here to say one method is better or worse, but these are all conversations I want to have with my students. In my class, actually, all the proofs that we ever do, they have unlimited attempts to retry. So if the first time you write a direct proof doesn't go well, you can try again, and same with the different method. Things get even more complicated if we have an indirect proof. So for instance, here's something you might prove with a contrapositive. And so we have an integer, and we're assuming that the square is odd, and we want to show the original integer had to be odd. A common thing students will do is they'll kind of end up negating the fact that x is an integer as part of the contrapositive. And so I'll see things like this on a quiz, like x is not an integer. This isn't exactly wrong, but the issue is that they haven't quantified the x in the actual proof, right? You should say where all of your variables live before you start talking about them. And even if this is in some sense correct, that might be the contrapositive of the statement, it's just very awkward to work with. But if I have exactly the same theorem written in just slightly a different way, then I don't think the student would make that mistake. I think with these instructions, you would probably get a near perfect proof, something like this. Finally, I think students will really learn from trying and then getting feedback and then getting a chance to try again.